Howdy everyone, this is Ryan with 50/50 Tech Area. Today we're going to be talking about heat energy. This is taught in both chemistry and physics. In this video, we're going to be using the formula Q equals mc delta T. Let's just go ahead and talk about Q equals mc delta T first, so we can get a better understanding of what it actually is and what we will be doing in the two problems in this video. So let's first write out the actual equation. Q equals mc delta T. Q here is just regular old heat. You can have two different units, but you cannot use them in the same problem. So in a problem you'll see either joules or calories. Joules or calories. In the two problems we will be doing, we'll use, in one of them we will be using joules, in the other we will be using calories. So we can work with both. M is mass. Again, you only have one unit, but if you are in chemistry, you'll be using grams. This is in chemistry. And if you are in physics, you'll be using kilograms. Because in grams you're doing smaller stuff like looking at atoms, measuring things, all that stuff. But in physics, you're measuring things that are bigger and have a bigger mass than what you're dealing with in chemistry. So, C is specific heat. Now, specific heat is different between different types of things that you'll be using. Lead has a certain specific heat, but it is not the same as ethanol's specific heat. You'll see specific heat of water and specific heat of ethanol in this video. In the unit, there will be 3 different units for the specific heat. In chemistry, there are 2 different types, but in physics there's only 1. So the 2 units are calorie per gram degree Celsius or joules per gram degree Celsius. So that's chemistry. And in physics, you'll be using just joules per kilogram degree Celsius. So chemistry is just one of these 2. In physics, it's just this one. So if you're chemistry, you will need to remember that the specific heat will be in grams. You'll see it right here. We'll be using these 2 problems here, like the 2 units for specific heat, which has 3 separate units in them, which is calorie per gram degree Celsius or joules per gram degree Celsius. You can also say it as calories divided by grams degree Celsius, same with joules. Now we have, if we go back up here, delta T. Delta is just another name for change in. So delta also means change in. So it means change in temperature. So it's going to be a change in temperature. So it's going to be a change in temperature. What you want to do with that is going to be the final temperature that you're given in the problem, and you subtract that by the initial temperature in the problem that gives you. In certain problems, you'll be asked to find the final or initial temperature. In one of the two problems that we will be working on, we will be working out how to find the final temperature. So we're gonna start working on the problems. Alright, our first problem here asks us how much heat in calories is needed to raise 20 grams of water from 5 degrees to 40 degrees Celsius. The specific heat is 1 calorie per gram degree Celsius. So it's talking about heat. So we want to write down the equation Q equals mc delta T. So what is heat? Heat is Q. We are looking for Q. We are given the mass, and we are given the initial temperature and the final temperature. So in problems like these, you want to identify the initial and final temperature. Usually they'll word it like this: from a certain degree Celsius to another degree Celsius. When it says from and it has that, this will always be the initial temperature. So water from 5 degrees Celsius, it's starting at 5 degrees Celsius, and it'll stop at 40 degrees Celsius. So it's initializing at 5 and it's finalizing at 40. So, and we also have our specific heat of 1 calorie per gram degree Celsius. For this problem, we will write out every unit so we can see if all the units cross out. So we want to write Q equals 20 grams times 1 calorie per gram degree Celsius times 40 degrees Celsius minus 5 degrees Celsius. Now we want to multiply all this through so the grams will cancel out and the Celsius will cancel out as well. So what we want to do is just go ahead and subtract 40 minus 5, so 40 minus, what's these? Let's just see. So it's going to be 40 minus 5. We all know that it's going to be 35, so what we can do is just do Q equals 20 times 35 calories. So we want to multiply 20 by 35. So Q will equal, so 35 times, what's these? 35 times 20, which is 700 calories. So the heat that is needed to raise 20 grams of water from 5 degrees Celsius to 40 degrees Celsius is 700 calories. So let's now go to our second problem, which is 300 grams of ethanol at 10 degrees Celsius is heated with 1,460 joules of energy. What is the final temperature? The specific heat of ethanol is 2.44 joules per gram degree Celsius. So, we'll again write out the equation Q equals MC delta T. So, we are asked to find the final temperature. So, we have been given our mass, we have been given our initial temperature, and we have been given our heat and our specific heat. So, we can do 1460 joules. We'll go in for Q because we've been given our regular heat. So 1460 joules I mean, equals the mass, which is 300 grams, times 2.44 joules per gram degree Celsius, times TF, which is the final temperature, minus 10 degrees Celsius. So now what we want to do is multiply. Actually, we want to cross out all the units here. So we were only able to cross out those at the moment. So it's going to be 300 times, 300 times 2.44, no, it's 300 times 2.44, that will equal 732 joules per degree Celsius. We will now write TF minus 10 degrees Celsius. If you go back to Algebra 1, you'll know that you will need to FOIL. If you don't know what FOIL is, you can go to one of my previous videos on YouTube, and there you can find the FOIL method video. So you'll distribute in everything here. So it's going to be 732 joules per degree Celsius minus, let's see, 732 times, oh come on, this is why I hate basic calculators, 732 divided by, no, times 10. That will equal 7320, but we have to make sure that it, we can just do 7320 joules. Notice how I just put joules for the 7320. Don't want to forget that there. Notice how I just put joules for 7320. What I did was, you just don't distribute the number. You also have to distribute the joules per degree Celsius here. So, joules per degree Celsius, if you distribute that in, the Celsius at the bottom will cancel out with the degrees Celsius here. But it won't cross out anywhere else. So, ooh, I'm just forgetting a lot of things here tonight, I'm guessing. Because there is no degree Celsius over here, I won't cross it out with that. So, we'll now add 7320 joules to both sides, plus 7320 joules. We'll do this basically, so joules 0.878. So 8,780 joules equals 732 joules per degrees Celsius. So Now, what we want to do is divide both sides by 732. Not only do we want to divide both sides by 732, we also want to divide both sides by joules per degree Celsius. If you know the rules of math, the 2 joules cross out, leaving us with just Celsius. Degrees Celsius equals TF. So we do clear this time. 8780 divided by 732. That will come out to be roughly 12 degrees Celsius, since we're just going to round up here. So the final answer for this problem is 12 degrees Celsius for the final temperature. We can plug it back into this equation, but you can do that on your own, but most likely that will be the correct answer. So that concludes today's lesson of heat energy. If you have any questions on any of the problems that I did, if you want me to go over more, just put them in the comments below. I will read them. I will try to respond to as many as possible. You can also suggest videos, topics for the next video in the comments below. I will also read those and see if I'm able to do those. So, Ryan with 5050 Tech Area signing off. See you later.